Good evening children. Welcome back to PESF EduHub online learning platform. We are in the second session of the chapter Periodic Classification of Elements in Chemistry. Hope you are well familiar with the part 1 of this chapter. Do you like to hear stories? I think so. So, let us begin with the story. Young Dmitri of Russia, to be more precise, Siberia, lost his father, who was a teacher, soon after his schooling. The big family was in financial crisis, but the brave mother of Dmitri shouldered the responsibility of the entire family. She compelled him to continue his studies and enrolled him in a university in St. Petersburg, far away from Siberia. It was the turning point in Dmitri's life. The young Dmitri was molded from there into world-renowned chemist Dmitri Ivanovich Mendeleev, whom the world studies even to this day. Mendeleev had dedicated his entire work to his mother, who, according to him, knew, with the aid of science, without violence, with love but firmness, all superstitions, untruth and errors can be removed. Dear children, this is the objective of learning science. Oh, this is the perspective you should develop as a student of science in your years ahead. Now, let us examine Mendeleev's periodic table. During the time of Mendeleev, 63 elements were known to the world. Mendeleev studied all these 63 elements one by one, and he noted the findings in a card. At the end, he sorted the 63 cards. He pinned together the cards which showed similar properties onto the wall of his room. For the study of chemical properties of these elements, he concentrated on the formation of compounds with hydrogen and oxygen. Why Mendeleev chose hydrogen and oxygen for his study? Do you know? Yes, it was the more abundant element present in nature, and it was very reactive in nature also. Moreover, hydrogen and oxygen both formed compounds with almost all elements. To his astonishment, he found that almost all elements could be included in the periodic table, and the elements were arranged in an increasing order of atomic mass. Another important point Mendeleev found out was that there were regular recurrence of properties of similar elements. That is, some elements with similar properties reappeared at regular intervals. Based on these findings, he postulated an important law which is known as Mendeleev's periodic law. The law states that the properties of elements are the periodic function of their atomic masses. So this is an important law based on which Mendeleev had put forward his periodic table. The law states that the chemical properties of elements were periodic function of their atomic masses. Now, let us examine Mendeleev's periodic table. The figure is given here. Let us see what all features we can identify from this periodic table. Mendeleev arranged the then known 63 elements in this table, and as you can see, there are vertical columns and horizontal rows in his table. The vertical columns are called as groups and the horizontal rows are called as periods in Mendeleev's periodic table. Another thing you can observe here is that there are 8 groups in total, out of which groups from 1 to 7 have subgroups also. They are subdivided into A and B subgroups, as you can observe from the figure. 8th group did not have any subgroups. And another point you have to note here is that inert gases were not found or discovered at the time of Mendeleev. The chemical property or the compounds of these elements formed with hydrogen and oxygen, called as oxides and hydrides. The formula is given on the top in the horizontal row. So the letter R represents the element to be used there. Accordingly, we can see the chemical formula of the compounds. So these are the essential features of Mendeleev's periodic table. Once again, let us revise the essential features of Mendeleev's periodic table. The elements were arranged according to the increasing order of atomic masses and similarity in chemical properties. Next, it contains vertical columns called groups and horizontal rows called periods. There are 8 groups in total, from group 1 to group 8. Each of the group from 1 to 7 is divided into 2 subgroups A and B. All elements of a subgroup have similar properties. Inert gases were not known at that time. Now, we can examine the merits and demerits of Mendeleev's periodic table. The points are tabulated here in this slide. Merits of Mendeleev's periodic table. The first point is grouping of elements. As we have already noted, we now know that the periodic table contains 8 groups. So, He could generalize the study of the then known elements into the study of mere 8 groups. The study of periodic table became more easier. The second point, gaps for undiscovered elements. So, Mendeleev boldly left gaps in his periodic table for the inclusion of elements not known at that time. Almost 8 elements which he left gap in the table were discovered later. So, these gaps left by Mendeleev proved as a motivator for the later chemist to discover new elements. Third point, the prediction of properties of undiscovered elements. Not only did he left gaps for undiscovered elements, he also predicted the properties of undiscovered elements. As you know, we have seen that the elements with similar chemical properties were grouped in same vertical columns. So, he could predict the properties of elements where he left the gaps. For example, let us take the case of a few elements. The elements which he left gap, he named it using a prefix eka. So, he predicted the properties of some of the then unknown elements. Mendeleev named them by prefixing eka to the name of preceding element in the same group. For example, eka aluminium. The gap, as you can see from the periodic table, the gap left was the element was later discovered as gallium. Next, eka silicon. Here, the element was later discovered to be germanium. Look at the table given here, and from that you can examine the atomic masses predicted by Mendeleev, eka aluminium, and the atomic mass of the later discovered gallium. In the same way, eka silicon and germanium, you can find out that they were almost same. Though this was the widely accepted periodic table of the time, there were some limitations also present in Mendeleev's periodic table. Now, let us examine what were the limitations in his table. The first one was position of hydrogen. You already know that hydrogen is the first member of the periodic table. So Mendeleev could not give a fixed position in the periodic table for hydrogen. Hydrogen had resemblance with both alkali metals, which is group 1A elements, and the halogens, group 7A, in certain properties. As you know, if we look at the electronic configuration of hydrogen and alkali metals, the electrons present in the outermost shell or the valence electron was same for both of them, that is 1. And another property which resembled hydrogen with halogens was that both hydrogen and halogens are diatomic molecules. The second point or the second limitation of Mendeleev's periodic table was the position of isotopes. I think you already have studied what is an isotope. Isotopes of an element have similar chemical properties but different atomic masses. So according to Mendeleev's periodic law, isotopes of an element must be given separate place in periodic table since they have different atomic masses, but they were not assigned so. The third limitation was that there was no regular increase in atomic mass. As we examine the periodic table, especially in the case of heavier elements, there was no regular increase in atomic mass from one element to another. So, as we move from one element to the next, it was not possible to predict how many elements could be discovered between the two elements, especially in the case of heavier elements. The fourth limitation was the existence of anomalous pairs. According to Mendeleev, he arranged the elements in the increasing order of atomic mass and also according to the similarity in chemical properties. So, in some cases, he had to deviate from his order. So, for example, the element cobalt with atomic mass 58.9 preceded nickel with atomic mass 58.7. The element argon with atomic mass 39.9 preceded potassium with atomic mass 39.1. So, such anomalous pairs was another limitation of Mendeleev's table. Now, let us examine some of the questions given in your NCERT text. The questions are here. The first one is based on Mendeleev's periodic table to predict the formula for the oxides of the following elements: potassium, carbon, aluminium, silicon and barium. So, by observing the Mendeleev's periodic table carefully, you can see that the formula for the oxide of potassium is K2O. Next, for carbon is CO2. For aluminium is Al2O3. And in the same way, you can observe the compounds of or the oxides of silicon and barium also from the Mendeleev's periodic table. The second question is to name any two elements which have been discovered later. That were left by Mendeleev in his periodic table. So, as we have already examined, Mendeleev predicted the existence of Eka aluminium, which was discovered as gallium later, Eka silicon, which was discovered as germanium later, and boron, which was discovered as the element scandium later. Now, the third question here is, you can get the answer from the tabulated slide itself. The fourth one, why do you think that the noble gases are placed in a separate group? Can you guess it? Yeah, noble gases are inert in nature. So they are usually non-reactive. Moreover, they are present in low concentration in the atmosphere. So we say them as rare gases. So they were discovered later only. Due to their inert nature, they generally do not form compounds with hydrogen, oxygen, etc. So they are placed in separate group, which was later discovered. So let us sum up today. Today we have concentrated specially on Mendeleev's periodic table. As we already studied, there were only 63 elements at that time. These elements were arranged by Mendeleev in a tabular form, which consisted of vertical columns called groups and horizontal rows called periods. He arranged the elements in the increasing order of atomic masses and the similarity in chemical properties exhibited by them. Then, the next thing we have studied here is the essential features of Mendeleev's periodic table. So by examining the slide, you can identify all the features in the Mendeleev's periodic table. Next, we have discussed about the merits and demerits of Mendeleev's periodic table. Till then there was a confusion prevailed as how to study about all these different types of elements. So Mendeleev's periodic table generalized the study of elements into mere 8 groups. That was the biggest achievement of Mendeleev. According to his arrangement of elements, he could predict the existence of many undiscovered elements, which actually paved as a motivation for the future chemists to discover new elements. Mendeleev was bold enough to predict the properties also of these undiscovered elements, which later proved to be similar to the prediction made by Mendeleev. Now, let us examine the limitations of his table. The first thing was that he could not give a fixed position for hydrogen, since hydrogen resembled both the group 1A elements or the alkali metals and halogens, the 7A group elements. The second limitation of Mendeleev was the position of isotopes. Isotopes are elements with similar chemical properties but different atomic masses. So according to him, the isotopes of the same element should be given different slots. That is another limitation. And the third one was the existence of many anomalous pairs. Though he arranged the elements in the increasing order of atomic mass, the element cobalt and nickel, where cobalt preceded the element nickel. The second one was the element argon and potassium, where argon preceded the element potassium, which actually should be kept after potassium according to Mendeleev's law. Though with all these limitations, it was Mendeleev's periodic table which unified the principles in chemistry for the first time. Dear children, please note down the important points presented in this class. Keep it for your future studies. Study well. Make use of your time. Stay home, stay safe. Thank you.